In this video, we'll talk about the derivative of a function. The derivative of a function y equal f of x of a variable x is the ratio between the change in y or delta y and the change in x or delta x. We write it as f prime of x equal delta y over delta x. Sometimes we write it as dy over dx. It's called the derivative of y respect to x. First, we find the derivative of y equal to. So we can draw the line y equal to in the xy plane. We have this is x, this is 0, and this is y. And this is number 1 right here. This is 2. So y equal to is this line. What are we going to do is we find delta y over delta x. We see delta y equal 2 minus 2 equals 0 over delta x. 2 minus 2 is 0. 0 over delta x, you got 0. So the ratio delta y over delta x in this case equals 0, or the derivative of a constant y equal 2 equals 0. In this case, you can see the change in y, which is delta y, is always equal 0. Because you can see at any point in this line y equal 2, x run from negative infinity this way to positive infinity, and y is always equal to. So which means the change in y is always equal 0. So that's why you get delta y over delta x equal 0 over delta x equals 0. Similar to the example before, when we find the derivative of any constant term, for example, y equals c, we want to find the derivative of y equals c. So first of all, we can draw the line y equals c in the xy plane. So this is x, this is 0, and this is y. So c could be positive or negative. For example, if I draw like this, y equals c right here, we can see delta y over delta x in this case will be equal. Delta y is the change in y, which means you can see at any point in this line, x is changing from negative infinity this side to 0 and to positive infinity in this way. But y is always equal c, which means y doesn't change in value, right? So delta y should be 0, or c minus c should be 0. And 0 over delta x, you write delta x right here. And then you see 0 over delta x equal 0. We write y prime equal f prime of x equal delta y over delta x equal 0. When y equal f of x equal c, c is a constant term. So the derivative of any constant term should be equal 0. Now let's work on some examples. Find the derivative of y equal 8. We can see 8 is a constant. So the derivative of y equal 8 equal dy equal dx equal dA over dx equals 0. How about finding the derivative of y equal x? First of all, we can draw the line y equal x on the xy plane. This is x, 0, and y. And the line y equal x like this. This is 45 degrees, right? Basically, we find dy over dx equal delta y over delta x, right? We can see at any point in this line y equal x. For example, I put it right here, right? this point, we can see y always equal x, which means delta y should be equal delta x. If we put another point right here, the change in y should be this line, and the change in x should be this line, and this line should be equal in length. So basically, delta y over delta x should be equal delta x over delta x equal 1. So the derivative of y prime equal f prime of x equal dy over dx equal dx over dx. You see, y equal x, so dy equal dx. And the result should be 1. What about the line y equal 2x? So we just do the same. We draw it to see the relationship between the variable y and the variable x. So this is y, this is x, 0 and y. The line y equal to x. For example, x equal 0, y equal 0, x equal 1, y equal 2. X equal 1 right here and y equal 2. And this is the line y equal to x. Basically, we find dy over dx equal delta y over delta x. You can see at any point in this line, right? For example, if I put this point, right? So the change in y is twice the change in x. You see, from this point to this point, you can see the rise is 2 and the run only 1. So dy over dx equal delta y over delta x equal 2 over 1. And this ratio equal 2. So we write y prime equal f prime of x equal dy over dx equal d of 2x over dx. You see why you write d of 2x? Because 2x here is y, right? You just substitute 2x in here. So d2x over dx is 2. What if we want to find the derivative of y equal x squared? There's a formula that I want to show you. If we have the function y equal f of x equal x to the n, so the derivative of f prime of x will be equal to n times x to the n minus 1. This is the formula. We can see in this case we have y equal x squared. So n equal 2 in this case, right? And then we can see f prime of x should be equal 2 times x raised to the power of 2 minus 1. You see, n minus 1 right here. We can see 2 minus 1 here equal 2 times, you see 2 minus 1 is 1. So x to the power of 1, right? And then equal 2x. Let's try another one. Y equal minus 2 times x squared. Let's find the derivative of this function, y prime. So basically, y prime equal minus 2 times x squared. All of them prime, right? So the constant term you put outside, minus 2 outside. And then x squared, you write it right here. And then you put prime side. So basically, this is equal to the negative 2 times the derivative of x squared. And you already know how to perform the derivative of a power function, right? Minus 2 right here. You see n equal 2 in this case, right? And then you put 2 here. You see? N down. This means number 2 down. And then x raised to the power of n minus 1, which is 2 minus 1. Now you see minus 2 times 2, you got minus 4. X to the power of 2 minus 1 or equal 1. X to the power of 1, right? Equal minus 4x. When we find the derivative of polynomials like this, you just put a constant term outside first, and then you're focusing on finding the derivative of the power function inside using this formula. Let's try to find the derivative of y equal minus 7 times x to the fifth. Y prime equal minus 7 times x to the fifth prime equal, you can see we put negative 7 outside because it's a constant term. And then x to the fifth, and then prime. X to the fifth prime is have the form like this, right? We put minus 7 here. Right here you can see n equal 5, right? We put 5 down, and then x raised to the power of n minus 1, which is 5 minus 1. You can see minus 7 times 5, you got minus 35, times x to the power of 5 minus 1 is 4. You put it here, and this is the answer. Now, let's find the derivative of y equal f of x equal 2 times x to the third minus 3 times x squared plus 7x minus 9. When we find the derivative of this whole expression, we can split the whole problem in smaller, easier problem like this. Y prime equal the whole thing's prime, right? We put 2 times x to the third prime. Subtract 3 times x squared prime plus 7x prime minus 9 prime. And you see the prime side here is respect to the variable x. So 2 times x to the third prime, you can put 2 outside because 2 is a constant term. And then x to the third prime minus 3, you put outside. X squared prime. And then 7x, you can put 7 outside. And then you can write x prime right here. Minus 9 prime is 0 because the derivative of a constant is always 0. You can put 0 minus 0 equal, you can see 2 right here. And then x to the third prime, we can see n equal 3. We put n down and then times x to the power of n minus 1, which is 3. You put it down times x to the power of 3 minus 1, which is n minus 1 right here. Minus 3 right here. And then x squared prime, you can write 2 down, you see, n down, then times x to the power of n minus 1, which is 2 minus 1. And then plus 7, you put it here. X prime should be equal, you see this is x to the power of 1, right? X to the power of 1, you put 1 right here, right? And then x raised to the power of n minus 1 should be 1 minus 1. x to the power of 1 minus 1 should be 0. Then 0 right here. It equal 2 times 3 is 6. X to the power of 3 minus 1 or x squared. You see minus right here. 3 times 2 is 6. Then times x to the power of 2 minus 1 is 1. And then you have 7 times 1 is 7. And then x to the power of 1 minus 1 is 0. X to the 0 equal 1. So this is 7. You put it here. So the final answer is x squared, so 6x squared minus 6x plus 7. And this is the final answer for this question. Let's find another derivative of y equal f of x equal 4 times x to the 5th minus 3x to the 4th plus 2x to the 3rd plus 4x plus 9. So similar to the example before, when we find the derivative of the whole expression like this, we can split this whole difficult problem into the smaller, easier problem. So y prime should be equal 4 times x to the 5th prime minus 3 times x to the 4th prime plus 2 times x to the 3rd prime plus 4x prime plus 9 prime. The prime side here is mean dy over dx respect to the x value, right? And it equal, you see 4 times x to the 5th prime. You can put 4 outside and then x to the 5th prime side right here. And then similar to that, 3, you put it outside. And then x to the 4th prime. Right here, similar, we put 2 outside. And then x to the 3rd prime. And then 4, you put outside. And then x here, you put prime size here. And then 9 prime is 0. Because the derivative of any constant term is 0. Now we see 4, we put it here. X to the 5th prime is similar to this formula before. We see we have the function f of x equal x to the n, and then f prime of x equal n times the power of x to raise to the power of n minus 1. In this case, you see n equal 5, right? So you see we put n down, which means you put 5 here. And then times 2x raised to the power of n minus 1 should be 5 minus 1 here. And then minus 3 right here. And then 4x to the 4th prime. So we put 4 down, x to the power of 4 minus 1 using this formula again. Plus 2 again. X to the 3rd prime, we put 3 down, right? And then times x to the power of 3 minus 1. And then you see 4x prime should be equal 4 times x prime should be equal 1 times x to the power of 1 minus 1, right? And then 0. We can simplify this by, multiply 4 times 5 is 20 times x to the 4th. 5 minus 1 is 4 minus 12. 3 times 4 is 12. And then times x to the power of 3. Plus 2 times 3 is 6 right here. And then x to the power of 2. Plus 4 times 1 is 4. And then x to the power of 1 minus 1 is 0. X to the 0 equal 1. So 4 times 1 times 1 equal 4. You see, this is the final answer for this question. Sometimes we need to find the derivative at a point. What do I mean by that? Let's work on this example. We have y equal x squared. First, we need to find the derivative of this function y equal fx. Y prime equal f prime of x equal x squared prime. We can see x squared have the form like this, x to the power of n. In this case, n equal 2. So x squared prime will be equal, we put 2 down right here, and then x raised to the power of 2 minus 1. 2 minus 1 is 1. So we got x to the power of 1, or this is equal to x. And this is the result for finding the derivative of y prime, right? But we need to find the derivative of this function at some given point. For example, at x equal 2. We can see at x equal 2, we have 2x will be equal 2 times 2 equal 4. So the derivative of this function when x equal 2, or we can say f prime of 2 will be equal 2 times 2 equal 4. But the question is, why we need to do something like this? It's because when we find the derivative at some given point, for example, in this case is the derivative at x equal 2, it will give us the slope of the tangent line at that point. Let me explain with this graph. We have y equal x squared. We need to draw the graph of it. So we already know it's supposed to be a parabola like this, y equal x squared, right? This is 0, 0, 0. Now we already figure out y prime should be equal f prime of x equal 2x. And then the derivative at some given point, for example, at x equal 2, will be like this, f prime of 2 equal 2 times 2. You can see number 2 right here, you substitute x in here, right? You got 2 times 2 equal 4. We can see at x equal 2, right here, and y will be equal 4. Because you can see y equal x squared and x equal 2. So 2 squared equal 4 right here. So what is number 4 here supposed to do, right? This number 4 right here is not the same as this number 4 right here. This number 4 here is represent different thing. It represent the slope of the tangent line at this point. What do I mean by that? Is if we draw a line that just touch the graph at this point, for example, if I draw like this, right? So the slope of this line is 4. And that's how you understand the slope of the tangent line at this point. Now let's choose a different point. For example, if I say that we need to find the derivative at x equal 1, you can see y prime is always equal f prime of x equal 2x, right? Now we need to find the derivative at x equal 1. So f prime of 1 should be equal to 2 times, we substitute x equal 1 right here. So 2 times 1 equal 2. We can see at x equal 1 right here, And then 1 square equal 1. So y equal 1. Right? 1, 1. And you can see the derivative at x equal 1 will be 2. This number 2 right here will represent the slope of the tangent line at this point. So this is the slope, right? And then the slope is 2. How about the derivative of this function at x equal negative 3? Let's find out. Y prime of negative 3 equal f prime of negative 3 equal 2 times x. And x here is negative 3. You put it here. So 2 times negative 3, you got negative 6. We have negative 3 in here, right? When x equal negative 3, so y equal negative 3 square equal 9. So the point is minus 3 and 9. So what is negative 6? Here is supposed to do with our point right here. Negative 6. Here is the slope of the tangent line of the function y equal x squared at this point. Which means if you draw the line that touch the function y equal x squared at this point, so it will have the slope equal negative 6. Or another word, if you draw a line that will go through this point, minus 3, 9, and it also have the slope negative 6, it is the tangent line of the equation y equal x squared at this point.